So we'll move towards the second categorization, which is aggregations and group by. There are around 12 questions here, so we'll see those one by one. Before that, we should commit our changes to the GitHub, so to avoid any losses of the data. Okay, so for this we'll do git add. Okay, I think cd SQL. We have to switch to this repo. Okay, so here the git dot file is present. So here all other files will work. Git status. Okay, there are three files that can be. So we'll do git commit -m. I'm adding the introduction and the basic select and filtering notebooks. Okay, so commit has been created. Now we'll push it. So git push origin main. So we'll push it to directly to the main branch. So you can utilize this repository to set up your work environment and create some DDL tables at your SQL server. So and you can practice the same by utilizing those notebooks. Okay. So we'll create a new notebook here again. So which would be like this one. Let me copy aggregations and group by. So we'll create the second notebook, which is aggregations and group by .ibynb. So this would be the second notebook to discuss about the second categorizations of the questions. Okay, so let's move to question number 13. So in the question number 13, so based on this aggregation and group by, there is a question which is like, how many employees are in the company? How many employees are in the company? So how we can calculate? So we can calculate it using a count star. Okay, so for this select count star from employees. Okay. I have to, I think it got disconnected. I have to connect it to the SQL server. Now it is showing invalid object name. So for this, I have to use SQL 100 database. So now command is successful. So let's run it now. Here we go. We get the 10 number of employees. Okay, so we can add the name to this column as total employee count. Okay, so we get the column name total employee count for this one. So since count star counts all the row including nulls, but if you specify specific column names inside a count, it only counts non-null values in the column. So in this case, count star works better because we have to calculate total employees count. So this is the fundamental aggregate function used in the almost every reporting query. So in the interview point of view, always explain the count star versus count column. A classic tricky question, what does count of manager ID return? It returns 9, not 10, because one manager is null if it is there. Okay. So we'll move to the next question, which is sum and average. Okay. So in sum and average, there is a question based on this. Find the total salary expenses and average salary for the entire company. Okay, which is find the total salary expenses and the average salary for the entire company. Okay, so how we can do this one? Okay, so we'll do like select. Let's first select the column. So we have to find the total salaries. Okay, we would simply provide the sum salary. Okay, as total salary expenses for the company. Okay, and second we'll calculate the average, which is average. Again, pass the salary column as average salary in the company. And third one is like calculate the total salary and average salary expenses uh, for the entire company. And okay, so this is it. Write it from employees. Let's run this one. So now we get like okay, total salary expense 82,700, and the average is same. Okay, so but like since both are same, we might get confusion like how it is providing the similar structures here. Okay, but it is not that case since we do have the 10 rows or 10 records, salary records in the table. So that's why it is just a difference of divided by 0. So if you see there are 8,27,000 total expenses while the average salary is 82,700. Okay, so in this case sum and average become the aggregate function and they ignore nulls. So while calculating the average, there should be sum upon non-null rows. If we do have the nulls into the salary column, then average salary may get changed. Okay, so it calculate based if there is one null value in the salary column, then the average calculated based on the remaining nine records. Okay, so let's move to the group by function, which is question number 15. So find the number of employees and average salary per department. Okay, so we'll move to the answer. For a number of employees, we'll just write the select statement. Okay, so number of employees and average salary per department. Now, notice here, like number of employees comes from the employees, but for a department, we should have the department table. Okay, since we have created these tables here, let's see what are the tables we have created to work upon. DBO department and employee. So we can fetch the record, select star from employees, and then select star from departments. Right, then execute it. Let's see where. Now you can see early, like department ID is mentioned in the department table along with department name, location, and department budget. Okay, so our question is like find the number of employees and average salary per department. Okay, so why we need this department? Because department 5 is not getting utilized in the employees table. So if you see in the employees table, department 5 is not there. For this, we have to join this department table with the employees table. So how can we do this one? Okay, so let's type the query, select department name. So department name comes from the department ID. So before that, we should have from employees as e. So we have to join. So just write the skeleton here. Skeleton department as D. So on e dot department ID equal to d dot department ID. So we'll join both the table based on the department ID. Okay. And after joining, we'll do the group group by based on the department name or department ID can be possible. Okay. We'll use the department name here and we'll do the order by. It is not mentioned in the question, but it is very good practice to do the order by the average salary per department. So average will create the column average salary. You might be confused like why the average salary is mentioned since we do not have the average salary columns in both of the table. So let's derive that column. Okay. Since we take the department name and then write the count e dot emp sorry e dot emp id so based on this column we have to count the head count. Okay, head count, and then after this we will calculate the average salary e dot salary. So as average salary. This is the salary. Okay, now we have created this one. So this join is by default as a left join. Okay, we'll can write the left join here as well. So okay, so you might see like there is an invalid object name which is a department. So it is right because it is a department table, not a department only. Okay, so we are able to join this table based on the department ID. Now we'll get the department name, head count, and their average salary as per the department. Okay, so we are getting the information from the department employee table. Since the department 5 is not available in the employee table, that's why the department 5 is not reflected in this, which is marketing department. Okay, so in the group by, actually it calculates uh, the aggregation by collapsing a rows and sharing the same group key into the single row. So every column in the select that is not an aggregate must appear in the group by or order by. And order by lets you sort the by the aggregate values. Okay. So every column did not to be appear in the group by, but there should be aggregation in the select clause. If you are providing the two non-aggregated columns in the select statement, then a group by may throw an error if you are providing only single column in the group by. You have to provide two different columns which mentioned in the select clauses. Okay. So this is the perfect query for our question, which is find number of employees and average salary per the department. So since it's the most common group by questions, and empathize the rule like non-aggregated columns in the select must be in group by. So interviewer also ask about grouping by the multiple columns that have to be prepared. Okay. So grouping by multiple columns, it collapse the row based on the groups of the columns that we have provided. Okay, let's move to the question number 16. So question number 16 is find the department where average salary exceeds 80,000. Okay, so in this case, like we know like, okay, find the department where average salary exceeds the 80,000. So in this case, what we need to utilize, so we have to calculate the average salary first, and based on that average salary we have to filter the records which salary exceed the 80,000. So in this case, where clause cannot be utilized, since where clause can be applied before the group by, but we see like here condition, we have to calculate the average salary as per the department, and based on the department, we have to filter out the salaries which exceed the department which exceed the 80,000 as average salary. So we'll utilize the previous query which is similar. So only things here we change here is like we don't need the head count here. Okay, only thing we change here is the having clause. So after the group by, we have to provide the having here. Having. So having a clause, it is similar to where clause, but it filter out the rows after the group by, after the aggregation. So in having clause, we can mention like, okay, so average salary should be greater than 80,000. Okay. If you run this, you will get those two records. Okay. We cannot mention this alias column here. Why? Why cannot be mentioned? Because having clause execute after the group by clause, but the statement mentioned in the select clause, it execute after the having clauses. So that's why we have to provide this entire statement in the inside the having clause. Okay. So to typical explanation would be having filter the group after the aggregation, and where filter the rows before the aggregation. You cannot use a where to filter on aggregated results. SQL execution order is like uh, from so let me write the execution order. SQL execution, sorry, SQL execution order. So it can be like from, then where, then group by, then after group by, then it's having, then after having it select, after select, then there is a order by, after order by, then there is a top or limit. Okay, and then there is a distinct as well, distinct. So this is the execution order. Okay, based on this execution order, we are cannot filter out the rows after the aggregations. That's why we have to utilize the having clause. So interview might ask like the difference between the where and having. So the where versus having distinctions is one of the most like most tested concept across all interviews. So they might ask write the execution order on the whiteboard if possible. The interviewer may ask you to rewrite a having clause as a subquery. So you have to be prepared based on the scenario if the interview cross question. Okay, so we'll move to the next question, which is a 17 number. Find the department. So we are moving to the difficulty level to the medium. Okay, so find the all the department with more than two employees along with the employee count. So what it exactly? You have to imagine the question like find all the departments with more than two employees. So they want to get those department whose employee count is um, more than two, along with uh, the total employee counts. Okay, so it is similar to the previous question, which one is like this one that find the number of employees and average salary per department. We copy the similar query, okay, and we made some changes here in the query. So now we do not need to average count the average salary. Okay, we just join based on the department since it asks based on the department. Okay, and we have to provide the where condition. Okay, now we are not calculating so now we did the aggregations here, so now we have to add the having clause because we need to calculate after the aggregation. So we will mention this here, having employee id is greater than more than two employees. Okay, along with the employee count, so they will mention it as a emp count, sorry, count. So you can see here like, okay, engineering and sales has been written 4 and 3 since its employee count is more than 2. So that's why it get written. Okay. Based on this left join on the employees and department and the join condition on the department ID, we are using it group by condition at the department name or can be used at the department ID and provided the having count e dot employee ID where the count is greater than 2. So using count star in having clause is valid if you want to count the all the records. Okay. But there might be chances of duplicate records or like a null records inside the employee ID. So we should use the employee ID since if it is a primary key, that would be the best practice instead of a count star. Okay, you can also use the alias in some databases, but for portability and repeat the aggregate in having. So note department ID one engineering has a four employees and it should appear. So it is appeared here, and if you provide the greater than equal to here, and it will provide the HR department as well. Okay, so we'll move to the group Y. There are the much more functions group by with roll up. Uh, so this is not much more utilized function since it actually generates subtotal row for each level of grouping and grand total row. And this is not the scenario where it get utilized. So it is least utilized functions in the SQL. Okay, so we'll move to the next, which is aggregated rating with the case when statement. Okay, so aggregation with case when statement. So question can be asked like in this case, question can be asked like we skipped the 18 number. So question can be asked like count how many employees are junior, mid-level, and senior in the single pivot like query. So pivoting can be done using pivot functions, but in SQL Server we do not have the direct keyword, so we have to utilize the case when statement for the aggregations. So how it get utilized? So to understand this query, you should know the pivoting. Okay. So in count, we can provide the case when statement. Case when salary is less than 65,000, then one. And then we have to end it here. And here we mention it as a junior, sorry, junior count. Similarly, we should mention the different again or other category, which is case when salary, sorry, salary between 65,000 and 90,000, then 1 and so this would be the mid level. Then again we should calculate for the senior level as well. Count case when but okay, case when salary is greater than 90,000, then one this would be senior count, mid level count, senior count, and okay, now we have give the source employees. It should work perfectly. Now warning, null value is eliminated by an aggregated or other AS set operation. So this is a warning that a SQL server provides you. So null value can be eliminated in these cases. So junior count is 3, mid-level count is 3, and senior count is 4 into the company. So conditional aggregations can be uses case when inside aggregate functions. When the condition is false, it returns null, and the count ignores the null. So only matching rows are counted. This is common pattern for pivoting data without using the pivot functions. But in SQL Server, we do not have the pivot function. We can use this case when statement. Okay. So let's move to the next question, which is 20th question. Find any email address that appear more than once in the customer table. So let's visualize the customer table. Select star from customers. Okay, let's visualize. Okay, so we do have the customer ID, first name, last name, email, city, country, and created at. And our question is find any email address that appear more than once in the customer table. So we have to write the query like based on the group by and having. So what we can do is we'll combine group by and having count star is greater than one in the standard pattern to detect the duplicates. If the groups it groups identical emails and filter for the groups with more than one occurrence. Okay. Even the email has a unique constant here. This pattern is invaluable in a data cleaning task. Okay, so classic data quality questions can be like show. You can also extend it to the find duplicates across multiple columns, like a group by first name, last name, and having count star is greater than one for the other columns as well. But in this case, we'll write the query like this: select email, comma count. So in the count, we provide the star as occurrences. Occurrences. Okay, from customers, customers, group by email, uh, having count star like occurrence is greater than 1. So if there is an email whose occurrence is greater than 1, then it should appear here. Now in current situation, there is a no entries whose occurrence is greater than 1. Okay. So if you like, okay, so we'll move to the next question, which is 21. So in the 21 question is based on the percentage of a total. Okay. So in the 21 question, we'll calculate show each department salary expense and its percentage of company total. So how can it be calculated? Show each department salary expenses and its percentage of company total. So for this, we have to visualize the department and the employees table. So we already had. So for this, we may not need it to visualize it again, but let's try to visualize. Select star from employees. Okay, and select star from departments. Okay, this is a mistake. So what we need to calculate here? What are the things to calculate? Show each department salary expenses. So now we do have the budget and we have the salaries. So we have to calculate the salary expenses, means sum of the salary based on the department and it percentage of a company total. So uh, we calculate the total entire amount of the salary, and based on that entire amount, we calculate the average total salary expenditure per department, and we calculate the percentage based on it. So for this, we have to join this department and the employees based on the department ID. So we'll write the query, select t.dpt name, comma, sorry, comma. Now we have to calculate the total salary here. So we'll calculate salary as a department salary. So total salaries per department needs to be count. So we now in the down the line we are gonna use the group by functions after the join, and again we have to calculate the percentage of total. So percentage of total can be calculated. So we have to round the sum of salary dot salary. Now the it calculate the sum. Then we multiply it by 100 and divide it by sum of salary based on the department. So how we can do this one? Okay. So now the sum of salary is calculated for that specific department. Here the aggregation comes, but we have to divide it by the specific department salary. Okay, they will calculate sum of. Let me write it clearly. Okay, will you utilize the second row divided by sum of salary, sum on e dot salary, sum on e dot salary over. So we'll use a window function here. So it will calculate overall, comma 2. So let me explain this one again. So sum of salary into the 100. So what it will calculate? It will calculate the department salary and multiply with 100 and divide by sum of salary over the entire cell. So why we are using a window functions over here, a window here? Because we need to calculate entire salary, total salary expenditure of the company. So for this, I have utilized the over clause here. Okay. So this has been completed. We mention its name as a percentage of total, which we need to calculate total, which we expected to calculate here. So now the here comes the join things. So from employees, okay, employees as e to join departments D on e.dpt id equals d.dpt, sorry, d.dpt department id on group by d.dpt name and order by dpt salary descending. So you this make it descending by dpt salary. So if you see here, like percentage of total is 47.4, 49.2, 13.3, and 10.2. So these are the department salaries. Based on that, these are the percentage. Okay. So this demonstrates the window function alongside the group by. So it's a kind of powerful combination and alternative approach using a subquery in the denominator is also valid but less elegant. Okay. So we can move to the next question, which can be monthly order counts. So we do have created the data definition language for this table orders. Let's move to the question number 27, the 22nd, which is show the total number of orders and total revenue for each month. So before that, we should see the table which is orders. Let's start from orders. So the orders table contains the foreign key, customer ID, order ID, order date, status, and total amount. So in this, we have to extract the total number of orders and total revenue for each month in 2024. In each month in 2024. So we need to extract the data of the 2024 only. And based on that, we have to calculate the total revenue in that specific month. So from the order date, we can see there is a 01, 02, and 03 month is there. So January, February, and March is there. So for these 3 months, we do have some sales revenue generated. We have to calculate the total revenue based on those months. So what we can do here is, let's select, like, if you want to do it in a single statement, we can do it, but we'll do it in some different manner. So let's select the order ID, total number of orders. So we have to calculate total number of orders and total revenue for each month. Orders and okay, for each month. So what we can do, select a month from order date as a month. Count, sorry, sum total amount is total revenue. And then we'll do the group by from orders. So you can see there is a first month, second month, third month, and there is a total revenue generated here. Okay, but there is another method as well. Okay, so we can use the extract keyword to order by, but this is the simplest method that I can utilize. Since I know like there is only 2024 data available in the dataset, we can utilize this method. But if you specifically want to handle this 2024, then we have to utilize the subquery. Okay, so let's move to the next question, which is 23rd. So we have to find the top n per group. So what is top n per group? And question number 23, we should find the highest paid employees in each department. So highest paid employees in each department means we have to find the employees, let's say top 3 employees or the highest to lowest paid employees in that order. So in each department, so we have to use the window functions over the departments. Okay, so what we can do is, let's select some columns, which is department ID. What are the first? Let's take the first name, FIRST name, last name, salary. Okay, so from where we want to select, let's create the subquery for this one. From again, we'll select this, select department ID, comma, first name, FIRST name, comma, last name, comma, salary, comma, again we have to use the rank over the, over the window based on the partition by, so we have to partition it by the department id, and we have to order it by salary in descending order. Salary in descending, we have to take the highest first, and we'll provide it as a rank from employees employees and we provide this as a rank. This, since it's subquery, we can provide the any name here and provide the where condition to calculate the top n highest paid employees salary. So we can provide it here is as a rank, which is already derived in the subquery. So we'll find the top 1%. Okay. So there are the one employees from each department who is highest paid in their department. Okay. So we have created a subquery. Inside the subquery, we have implemented the window functions to partition it by the department ID and order by the salary in descending order. Okay. And from that subquery, we have filtered it out based on the rank. Okay. Similarly, there is the next question which is related to the running total, which is cumulative sum. So what is the question for this cumulative sum, which is like show the each order with its running total of revenue order by order date. Running total means what is the running total orders till January month. So what is total order till February month? So in February there is order from January and February. What is the order till March month? Then in March month it contains all the order from since January to March. Similarly for the other months as well. So these are the running total. So how it is calculated based on this like based on the window functions. So let's see the code block how it looks like. Okay, let's create the code which is select. Let's say let's see this table first. Let's select star from orders. Now there is a 1, 2, 3, 4, 5 columns is there, and we have to each order with its running total revenue order by the order date. So we'll take the select. We'll take the order ID t comma total amount, and then we'll calculate the running total. So running total is like calculate the sum. So sum over the total amount over in over clause we have to provide the frame clause. Okay, in frame clause, but we have to order it by the order date. So we need to provide the ordered order date. Sorry, order date. So and the rows between unbounded preceding and current row. So it will calculate till current row as a running total. So from orders and order by order date, comma order ID. Let's try to run this. So there is a syntax error in the play. There is a double E here. This should not be. So if you see here, like it did the order order by the ascending by order date. Let's see the order data as well in the output columns. If you see, like there is a order date column by it is order by order date, and then inside or after the order date there is the order by the order ID. Okay, then this is the running total calculated based on those columns. So if you see that 1285 is here, and then again 710 is a total amount and for this order ID, but this get added into the above. Again this 95 get added into the 1995. Again this get added. So similarly it get increasing till down the line. Okay, this is how we see these many aggregations and the group by functions. Okay, so let's recap what questions we've seen so far in the aggregations and group by category. So first question is how many employees in the company? We simply use the count star from the total and alias it as a total employee count. Second question is find total salary expenses and average salary for the entire company. So we use average and sum functions over the column salary. Again, 15th question is just find the number of employees and average salary per department. So in this, we join the employees and department column on the left behind on the employees. So we figured out the head count of employee from the employees table and calculate the average salary and group by the department. Okay. So next question, which is find the department where the average salary exceeds the 80,000. In a similar way, we do the left joined employee table and calculate the average salary and use a having clause to filter out the data whose salary is greater than 80,000. So we also discuss the execution order of the SQL, which is from here group by having select an order by, and then last one is the top limit and distinct. Next question, which is 17 number, find the all department with more than 2 employees along with the employee headcounts. So it is similar to the previous one. Yeah, we do the left join on the employees table based on the department table, and we implemented the count filter in the having clause to filter out the employee headcount whose department ID whose headcount is greater than or equal to 2. Again, in 19th questions, we have to calculate the number of employees, and we have to categorize the count based on the junior, mid-level, and a senior. So here we, instead of pivot functions, we use the case when statement inside the count, and we are able to segregate based on the categorizations. So 20th question is find any email addresses that appear more than once in the customer tables. We simply use a count star as a occurrence and join it on the department tables and oh, sorry. We simply use count star as the occurrence for this one. Since we do not have any duplicate email address, it returns nothing. So 21st question, which is show each department salary expenses and its percentage of a company total. We calculated based on the sum and window function. So window function is utilized here to calculate the total from the salary. Okay, and it is divided by the sum of salary based on the department. And 22nd questions, we have to calculate the total number of orders and total revenue for each month. So here we utilize a month keywords to group it by that specific month. In 23rd question, which is finding the highest paid employees in each department, we use a subquery. Inside subquery, we use a rank function with the window function by partition by the department ID, and we filter it out based on those ranks. And last question, which is 24th, the question was like, show each order with its running total of revenue ordered by the order date. So we calculated here the running total based on the sum over the window clause and created a frame clause which is rows between unbounded preceding and current row, which calculated the running total till current row. So similarly, we can also calculate the rolling total as well. So we don't need to specify this unbounded preceding. Instead, we can specify the row number for the rolling total. Yeah, now that's it in the aggregation and group by. We'll see the next topic, which is joins in the next video. Thank you so much.